Applications of linear equations in daily life. In this module, we are going to check some number-related problems solved with linear equations. Welcome to Mathematics of Engineering. Linear equations can be solved in different ways. The most basic we are going to discuss in this module. First, by graphing linear equations, the intersections of such lines will be taken as the values of the variables involved. Although there is no computation required in this method, accuracy in scaling and graphing points are necessary. Another means by solving linear equations algebraically is by substitution method. This method employs replacing one variable with the other to reduce the number of variables in a single equation. With one unknown in an equation, it is solvable. Take this for an example of substitution. Solve for x and y from the following equations. Negative x plus y is equal to negative 5 and 2x less 5y is equal to 1. Let's denote the first equation as equation 1 and the other as equation 2. From equation 1, we can extract one variable to a side and make it as a function of another. In this case, y is equal to x minus 5 and designate this as equation 1a. We can now substitute equation 1a to equation 2. Hence, 2x minus 5 times the quantity of x minus 5 is equal to 1. By distributing 5 to the terms in the parentheses, we get 2x minus 5x plus 25 is equal to 1. And simplifying the terms, we arrive at negative 3x is equal to negative 24. Then, by dividing both sides by negative 3, we get the value of x equals to 8. After learning the value of x, we can now use the value to determine the other variable using equation 1a. That is, y is then equal to 8 less 5, which gives the value of y as 3. Check the values by plugging both in equation 2. So 2x minus 5y is equal to 1 would turn out as 2 times 8 minus 5 times 3 is equal to 1. Which gives us 16 less 15 is equal to 1, and indeed 1 is equal to 1. Hence, the values are x is equal to 8 and y is equal to 3. The third method of solving linear equations is through elimination. This is done by organizing all terms with variables on one side and constants on the other. Next is using the appropriate operation to eliminate a variable until one unknown is left in an equation. And just the same, check values by placing them into the equations. Let's work on the following example. Solve for x and y from the following equations. X less 4y plus 19 is equal to 0, and negative 2x plus 4y less 22 is equal to 0. Again, let us designate the first equation as equation 1 and the next as equation 2. Start by placing all variables on one side and constants on the other. Take note that if we add the equations, we can cancel the y variable. So, x take away 2x is equal to negative x, negative 4y plus 4y cancels out, the negative 19 plus 22 is equal to 3. Thus, x is taken as negative 3. Next is to determine the value for y. By using equation 1, we can plug x and come out with negative 3 minus 4y is equal to negative 19. And moving the constant to the other side, we get negative 4y is equal to negative 19 plus 3, resulting to negative 4y is equal to negative 16. And dividing both sides by negative 4, we get y is equal to 4. Check the values by placing them in equation 2. Negative 2 times negative 3 plus 4 times 4 is equal to 22, which would give us 6 plus 16 is equal to 22. Therefore, 22 is indeed 22. Hence, x is equal to negative 3 and y is 4. An application of linear equations is to determine values in number-related problems. For example, the sum of two numbers is 19. The larger number is 1 more than twice the smaller number. What are the numbers? We denote x as the larger number and y as the smaller number. In the first statement, it states x plus y is equal to 19. Let's take this as our first equation. From the second statement, the larger number is 1 more than twice the smaller number, and this is denoted as the second equation. By substitution of x into equation 1, we can get 2y plus 1 plus y is equal to 19. And simplifying, we arrive at 3y plus 1 is equal to 19. We then replace the constant to the other side and get 3y is equal to 19 less 1, or 3y is equal to 18. By dividing both sides with 3, we get y as 6. Now, take equation 2 and replace y by 6. That is, x would turn out as 2 times 6 plus 1, which would be x is equal to 12 plus 1, or x is equal to 13. Lastly, check the values of x and y using equation 1. That is, x plus y is equal to 19, or 13 plus 6 is equal to 19, which indeed turns out as 19 is equal to 19. So we can conclude that x is equal to 13 and y is 6. Let's solve the other example. Find two consecutive even integers such that the square of the larger is 44 greater than the square of the smaller integer. We assume x as the larger integer and y as the smaller integer. From the first statement, it states that x is equal to y plus 2 as they are consecutive even integers, and we designate it as equation 1. The second statement provides the other equation stating the square of the larger is 44 greater than the square of the smaller integer. And this we will call equation 2. Using substitution of the first equation to the second, we would get y plus 2 squared is equal to y squared plus 44. Then expand the left side, it would result to y squared plus 4y plus 4 is equal to y squared plus 44, whereby y squared can be cancelled out and the constant moved to the other side, which would result to 4y is equal to 44 minus 4, or 4y is equal to 40. And again, by dividing both sides by 4, we get y is equal to 10. Next, replace y by 10 in the first equation. That is, x is equal to y plus 2. So, x is equal to 10 plus 2, bringing the answer x is equal to 12. And lastly, check the values by plugging them in equation 2, which states x squared is equal to y squared plus 44. So bringing 12 squared is equal to 10 squared plus 44, which shows 144 is equal to 100 plus 44. Eventually, that would be 144 is equal to 144. Thus, we can say that x is equal to 12 and y is equal to 10.